In this video, we will look at how to declare and use two-dimensional arrays in C++. Let's start with the program that you see on screen and go through it. So it is a shell. We have to fill in all of the code that we're going to be looking at, and we have to put the functions at the bottom. Starting out at the top, I want to show you a couple of things. You can do either one or the other in C++, so you may be familiar with them, you may not. But if you want to declare an identifier and set it to a value, then you can use the #define feature. In this case, we're using #define, and I'm using the uppercase variable rows, and that's just convention. When you're using a #define or when you're using a constant, typically the identifier is uppercase. So in this case, I want to let the identifier rows be equal to 20, and this is the syntax for doing it with a #define. You can also do the same thing with a constant declaration. So down below, I'm declaring a constant. The constant is going to be an unsigned integer. It's going to be called columns, or COLS, and I set it equal to 10. But notice that the syntax is completely different for this one. The other thing that's different is that the #define is processed at what we call compile time, and it does not occupy any location in memory. So this thing, this identifier rows, it doesn't have a storage location in memory, but the constant will. Okay, the constant is going to have an address where it will be stored in memory, and it'll be called columns, and it'll COLS, and it'll be set to 10. Now, once you declare a constant, then you can't change it. Okay, columns, if you try to change it in your program, then you'll get an error. But nevertheless, it is stored in memory, whereas the #define is not. So that's maybe something new in C++ you didn't know about. Now, our goal in this program is to look at two-dimensional arrays. So this skeleton program already has a bunch of things declared. So you see we have some unsigned integers here, and mainly those are going to be the result of the arrays, of functions operating on the arrays. And then I've just got some cout statements indicating what we're going to do as we proceed through the program. Now, before we go and add code in all those places, let's just look at how we would declare a two-dimensional array up here at the top. So when you declare a two-dimensional array, then you do so by using the double square brackets. So for example, if I want to declare an array called numbers, then I could do it like this. So again, you have the type, you have the identifier, and instead of having a single square bracket with a number, then you have two. So this is a two-dimensional array. It has 3 rows, and each row has 4 numbers, or 4 columns. And if you wanted to do multiple dimensioned arrays, then you just add on additional square brackets with numbers over here. So you can have a multi-dimensional array as well, and you can put as many of these here, as many dimensions as you want, that else you can tolerate as far as debugging is concerned, and you're limited really only by the storage space, the memory space in your computer. But we'll stick to two-dimensional arrays to begin with. Now, if you want to declare them and initialize them, then of course you can do that as well. Now the syntax is going to look a little different, so let's take a look at the syntax for that. So I'll just go ahead and add in an example here. So let's paste that in. And here's how you do it. So let me align some things here. Let me move that over, and that over, and this, and then I want to move this closing brace over here as well. Now, I could have put all of those on one line, but it just looks like a two-dimensional array if I do it like this. All right, so when you declare a two-dimensional array, you can initialize it like this. We have an open set of curly braces here, and then for each of the rows, we have another set of curly braces, and we have the numbers that go on that row. So in this case, it's just even numbers. Okay, so row number 1 will have the numbers 2, 4, 6, 8. Notice that they are separated by commas, and you do put a comma after the closing curly brace here. So that would be the numbers that you would initialize for row number 1. Then, after a comma, you have the numbers for row number 2. There's a comma. And then and you have another set of curly braces with numbers, and that will be row number 3, and you don't have to have this comma here. Okay, then you enclose the entire thing with a closing curly brace down here. So that's the syntax you would use if you want to actually go ahead and put some numbers in for your two-dimensional array when you declare it. Now let's suppose you want to declare a 2D array and just want to set everything to 0. Well, that one's really easy. It's like we did with a one-dimensional array. So here's an example of that. In this case, I've got a float, and it's called values. It's 20 rows and 15 numbers in each row. But if I just put a curly brace, 0 curly brace, then that initializes the entire array to 0. So this works here as well. In fact, it works for whatever number of dimensions you have. You can always initialize the entire array to zeros by using this. And remember, 0 is the only one that you can use. If I try to initialize everything, say to the number 5, then that isn't going to work. Okay, so it only works if you put a 0 in here. All right, so then here then is the syntax for declaring and initializing some two-dimensional arrays. All right, now let's move on to the other part of the program. So we're going to print out. We'll print out two-dimensional array operations, and we'll examine some operations. One thing we'll need to do is we'll need to initialize the array, and then we will print out the array. So we're going to need a initialize function and a print function. So let's go ahead and write those functions first. So in this example, here is our skeleton for the initialize array. I'm sorry, the initialize function to initialize a two-dimensional array. When you are sending a two-dimensional array to a function, then we have to specify a number for the second dimension, and if there were other dimensions, we need to specify the size of those as well. When we had a one-dimensional array, we didn't need to do that. Okay, we just had a single set of square brackets, and we didn't have to put a number in there. But if you have a two-dimensional array, then you must specify how big that second dimension is. So that's a requirement. The program will not run unless you put a designation here for the number of columns. Now, I've already declared this columns as an identifier up here. So wherever you see the columns, this constant, then you know that that's going to be replaced by 10. And anywhere you see rows, then that will be replaced by 20. So in the function, then this is the same thing as saying I will have 10 different columns, or 10 columns in the two-dimensional array. So I don't have to specify that one. I do have to specify this one. Now, I'm going to send in to my function the number of rows that I have and the number of columns that I have. So that's just my way of doing this. I could have used this number here, but as you'll see coming up, these numbers don't have to match. Okay, this number has to be whatever the dimension of the array is. But I might only want to initialize, the first 2 rows instead of the first 4 or 10 or whatever there might be. So I'm going to allow myself the flexibility to specify how many rows and how many columns in the array that I really want to initialize. Now, let's put in the code we need here to put some random numbers into our array. So here's the code to do that. Now, when we have a two-dimensional array, we have to visit each element of every row and every column. So we need a nested for loop to do that. So the inside for loop is going to go across each row and give the value for each number of that row. So that's going to be the number of columns. So my J index is going to start at 0, and it goes up to how many columns I want initialized in J++. And the outer loop, the for loop that is on the outside, that's going to go over all the rows. So to begin with, I is equal to 0. We go into the inside loop and we cover all the columns. So that would initialize the first row of the array. Then we go back to the outer loop. I will go to 2. And then we go to the inner loop and we initialize all the numbers for that row. So I think you understand what's going on here. All right, so this little function then is going to accept a two-dimensional array, and the formal argument is just called array, and it will just go through this doubly nested for loop and it will initialize everything to numbers between 0 and 99 like you've seen before using the rand function. Now I didn't, for some reason I didn't put my return here, so I need to go ahead and type that in. And with a void function you don't really have to do that, but it's good programming practice to always do this. Alright, so there is our initialize function. To complete it, we need to have the prototype. So I'll copy the first line and I'll make a prototype up here, add a semicolon. And now let's do the print array function. Okay, print array, it's going to be very similar. We'll still need to have the double nested loop to print out every single item, but we're not going to initialize it, we're going to be printing it. So let's add the code to do that. So here's the function. And the print array, I'm calling it, it's going to have exactly the same arguments as we did with the initialize. So we'll have a formal argument called array, and it has to have the square brackets. Now, if you wanted to put rows here, you could. There's no real disadvantage to that, but if you want to leave it blank, then you can. And that's typically the way it's done. But over here, we have to always specify how many columns. So this is the same set of arguments as we had with the init array, or the initialize array. And now inside of our loop, we are just going to print out each and every item, and we have to go through all the i's for the rows and all the j's and visit every single element of the two-dimensional array to print it out. So inside our inner loop, I'm just going to have a set width of 3, and we're going to print out one row. So the inside for loop is right there. Let's put this curly brace on the next line. So here's the inner for loop, and it prints out one row of the array. After we print out one row, I'm going to do an end line so that when we come back and print the second row, then it will be on a separate line. So it'll look like a two-dimensional array. And then we have the return. It's also a void function. All right, so now let's make our prototype. We'll copy and paste here, add the semicolon, and now we can use those functions to initialize the arrays that we have. Now, I had this example already, so I guess it's okay to leave it there, but I need to declare the array that I want to initialize. This one, numbers, that's already initialized using the static numbers that I employed when I declared the thing, and this is all zeros. So let's declare another array here. So I'll declare another array, and drawing from my example, I also called it numbers, so that is not going to work. So let's go back and rename this array up here, and let's just call it items, and then that way we won't have a conflict of the names. All right, so here we go. I want to declare an array called numbers. It's going to have that many rows, that many columns. So as you can see, it's using those constants. Okay, so rows will be 20 and columns will be 10. And that's because of the pound defined in the constant up there. So that declares it sets it all to 0. Now then, let's use those functions to initialize and print out the values. So we will initialize the array. So let's call the initialize function here. And we call it by just using the name. And I'm going to send in the two-dimensional array numbers. Remember that when you are passing an array to a function, you never use a square bracket notation in the call. So this is going to be the name of the array, and it doesn't have any square brackets. I'm also going to send in how many rows that array has and how many columns it has. So again, I'm going to use the constants that I defined up above. Then I want to print out everything that I initialized. So let's call our print array in order to print out the data. So we'll paste that in here. And the print array, we call it and we send it the same arguments. So as the program stands right now, we are just going to initialize the array and print out the values. And we'll fill in the other stuff as we go. All right, now let's see if I can compile a program. It may complain because I don't have values for these, but we'll find out what happens. So let's go ahead and compile the program. Okay, well, it did give me an error because it said that the sum is declared but not used, and average is declared and not used. All right, well, if you're running Visual Studio, then typically that's what happens. If you're running another kind of compiler, you may or may not get that error. The solution to this is really just to initialize the variables, which I failed to do when I declared them up here. All right, so I'm just going to go up and I'm going to set sum equal to 0, and I'm going to set the num also equal to 0, and go ahead and set average equal to 0 as well, so that we don't get that error. So now let's try that again. Equals goes there. So the output looks like this. So it looks like we did initialize the array, and it looks like we did print it. So in this case, we have 10 numbers across and we have 20 of them down. So that's a lot of numbers. But this shows that the calls to the function worked, and it does show you the syntax that you have to use when you are calling a function using a two-dimensional array. Now, we've got some other stuff to do, so let's go in and add the code to do those other operations. Let me also, just for fun here, let's print out the items array. Okay, let's send in the items array, which is 3 and 4. So let's send it in to our two-dimensional array. So let's see, it's already initialized. So now let's print it out. All right, so I'm going to change this. I'm going to do a copy and I'll do a paste. And instead of sending in numbers, I'll send in the array items. Okay, there's items. And it had, 3 rows, and it had 4 columns. Okay, so that's what we had up here, right? We had 3 rows, we had 4 columns. The array is called items. Okay, undo that. And here are the numbers. Now, when I try to call that, I get an error. So in Visual Studio, I've got the red underscore, the red squiggly line under here. So that means there's an error. So why can't I call printarray? Printarray is going to accept an integer array. That's fine, isn't it? With rows and columns. But I get an error. I get an error. So if I hover over the error, then it gives me some information. And now notice here it says the type integer *4 is incompatible with the parameter type integer *10. All right, now that means that I'm trying to send in an array that has 4 columns, and the function is accepting only arrays that have 10 columns. So whenever you write your functions for a two-dimensional array, this is what you're going to run into. The function that I wrote specifically says that I can only send in a value for the columns of 10. So that is a restriction. If I wanted to send in the array items, then I would have to make up another 7 rows and make this a dimension of 10. Okay, so if the rows part of this is 10, I would have to go ahead and initialize some other numbers here, and then I could send it into the array. Okay, now as it turns out, the remaining 7 rows are going to be whatever they're going to be. But now that I've made this array a 10-column array, I can call printarray to print it out. All right, now let's see what we get when we do that. And let's add the another cout statement so we can separate these things. Okay, so put a copy, I'll do a paste, and let's put array items here so that we know which one we're printing out. Okay, now let's compile the program and run it again. Okay, now we have the output, so let's bring that over. Okay, so here is the first array. That was the big one, that was numbers, so that one's still there. But when I print out the contents of the array items, now I can print them out. I do not get an error. So what's going on? Well, I'm now compatible with the function. When I change the dimension of the array items to 10, then the function now is compatible with that two-dimensional array. When I called the function, I said, I just want to see the 3 rows and the 4 columns. I don't want to print anything else. So this array items, it only had 12 values that I care about. But when I declared it, it has 30, and I had to do that because the columns has to match. What if I call that array, and instead of giving it a 3 rows and 4 columns, what if I change that to 10? Okay, what's going to happen now? Well, let's run the program again, and let's see what the output is. Now we have the output. So if I bring this over, when I change the call to 10, okay, 3 by 10, then the output looks like this. So I get the first row, and I get an additional 6 zeros. So the extra space is going to be set to 0 in this case. Now, I can't guarantee that for every compiler that you might be using, but this does work in Visual Studio. So I get my first 3 rows, or this row 1, row 2, and row 3. But because I had to make it compatible with the function, then I've got this extra set of zeros on each row that I don't really need. I just had to do it in order to be able to use that print array function. So that's kind of a restriction on using two-dimensional arrays with functions. You end up having to make this second dimension, the columns dimension, you end up having to make that as big as the largest array that you would ever expect to pass into this function. You can pass in smaller arrays, but the arrays all have to be kind of modified or artificially to make them the same number of columns. In future videos, we will see how to get around this restriction. So that's the thing, and this illustrates why that you have to be very careful with two-dimensional arrays. You always have to specify that second dimension in your function call, and that causes us some problems, as I've just pointed out. Now, let's go ahead and let's just look at the mechanics then of using functions to do some of these other things. And let's just remove our print array with items to get that out of the way, and we'll move on from there. Okay, so let's just delete that, and we'll go back to here. And let's go back up to the declaration, and let's put that back to 4. All right, so now we're good to go, but of course, we can't print out that array using the print array function that we have. All right, anyway, you see the problem here. We're going to abide by the rules. We're just going to use the array numbers because it has the 10 columns we need here. Okay, yeah, 10 columns is correct. As we move down, the next thing we want to do is we want to add all the elements of the array, and we are going to write a function to do that, and we will print out the results down here. All right, so now let's go ahead and write a function that will add up all the elements of the array. So we'll move down to where the functions live, and we'll paste in our new function. This function, notice it is not a type void. It's type integer. It is going to return the sum of all the numbers in the array. It's called the sum of elements, and it has the same set of formal parameters that the other two functions had. Then inside, we are still going to have to go through every single element to add them up. So when you're processing a two-dimensional array, just like we did with a one-dimensional array, we can't do an aggregate operation. We have to go to each and every element in the array, access it, and do what we want to do with it. In this case, we just want to write a cumulative sum. So our inner loop is going to go over the rows, and it's going to add up all the numbers in a given row, and then we'll go back to the top of our outside loop, move down to the next row, and then we'll add up all the numbers in that row. When we're done, we'll have one number, which is the sum of all the elements in the array. Then we'll just return the sum. So hopefully pretty straightforward there. Let's make our prototype. We'll do our copy and paste. Got to make room for that up here. Paste that in, add a semicolon. Now we're ready to call the function in order to add up all the values. Okay, so here is where we do that. We're going to add all the elements, so we just need to call it. Okay, now, something special here. Since this function is returning a value, then I have to have a variable in my main program that will accept the value that it returns. This is something that's often missed when you're writing your functions and calling your functions. So if it returns a value, then your program must be able to accept that returned value. So let's move up to our call, and let's add a call to the function that will do that. So here is a call to sum of elements, and here are the parameters that we send it. It returns a value, and I'm going to save the returned value in sum, which is a variable that I've declared up here at the top. So the main program has its version of sum, and the function also has its local version of sum, two separate variables, which you know now from the scope rules. So the function is called, it does add up everything, it returns the sum, and I do already have the cout statement here that will print out the sum. So that's fine. Then we will move on, we'll compute the average. But first of all, let's run the program and let's see what the sum of those numbers is. The output gives us the sum of the elements is 9,427. So that seems reasonable. So we have our array here of our 200 numbers. We add them all up, and we get close to 10,000. We haven't done the average yet. We'll do that next. So now let's go back and let's do another example function where we will get the average of the values. So we need to write a function to do that. Then we will come back and we'll print out the average here. Okay, so let's now write the function to compute the average of all the values in the array. This function is a type double, so it will return a real number, and the name of the function is just the average of the elements, and the parameters are exactly the same as all the other functions in this program. And here I've got the local variable avg declared as a type double, and we still have our doubly nested for loop. Well, in this case, we just want to compute the average. So we'll take the sum that we just did from the previous program, and in fact, I could have called that function to give me the sum here instead of actually doing this loop. But at any rate, I'm going to add up all the numbers and save that in sum. Then I'm going to compute the average with this line right here. Now, this may take just a little bit of explanation. The average is a type double, but all the numbers in the array are integers. So there's a type mismatch there. Okay, the number of rows and columns, those are also integers. So I've got a total of the number of rows times the number of columns, which in our example is 200. So I've got 200 numbers. So if I take the sum and I divide it by the total number, that gives me the average, just a normal average. But I want this to be a type double that I'm returning. So this thing here, okay, this double in parentheses, that's what we call a typecasting operation. So what that does, it's going to temporarily take the value that's produced here, and it's going to turn that from a integer value. Okay, so sum's an integer up there. So this whole thing would be an integer if I didn't do it this way. So I'm going to use this typecasting or coercion operator to convert the value that's computed here from an integer into a double. So that's what that's doing. And you can use this to change the type of a variable for only that one line of code whenever you choose to do so. So once we've changed that type to sum, when we get the value, we do the division, then we return the value for average. All right, now we need, of course, to do our prototype for this one. So we'll copy and paste as we are accustomed to doing now, and add the semicolon. So the function will return a type double. Now to call it, we go down to where we're computing the average. Okay, the average of the elements in the array is printed out there, so the call has to go here. Okay, so we just call the function in order to give us the. So here's the call. And I'm saving the value returned by the function in my local variable average that's in my main program up here. So then the function returns the value. I'll save it in average, and then I've got the cout statement here that prints out what the average is. So this will give us the average of those numbers. Then we're almost done with this. We'll find the max and min values next, but let's go ahead and run the program and determine what the average is. The output looks like this. So the average came back as 47.135. So that gives us the average, and that makes sense. You know, the numbers are between 0 and 100, so you would expect the average to be somewhere in the middle, and it appears to be. So that takes care of the function average. Before I move on, I want to format this. I realize that I didn't do any of the manipulators. So I'm going to do the cout. I'm going to make it fixed. I'll set the precision of 2. All right. So if you don't do that, then the actual formatting of this is kind of undetermined. You're not quite sure what the default is going to be. So anyway, let's go ahead and include that as our format for printing out the average. And in so doing, then we'll also use that to print out the, well, we won't use it for max and min values because those are going to be integers. So this precision only works with a real number, as we know. All right, now let's get the function that will find the max and min values. So let's paste in these functions. And I have written functions before that would find the max and the min within the same function, and then it would return them as arguments up here. So you've seen that example already. In this case, I'm going to have separate functions to find the maximum and the minimum. So I have the function called minimum. It's going to return an integer, and it has the same set of parameters that all the other functions do. And then just inside the function, we'll use our doubly nested for loop, and it will find the minimum value, and it will return it. Same thing for maximum. So I've got a function called maximum, and it's going to test to see if we can find the maximum. So we then, again, have to go through the doubly nested for loop. We have to look at every single element in the 2D array. So that's what this one does, and it returns the maximum. So in order to get the maximum and minimums, I do need prototypes. I'm going to have to call 2 functions, and that's fine. So let's make a copy of maximum, the first line, and paste it in for our prototype. So that's maximum. And then let's go ahead and do the minimum. So I'll copy the first line of the function minimum, and that will be my prototype. We'll paste it up at the top, and we'll be almost done with this example. So there we go. We have the prototypes for maximum and minimum. Then I just need to call maximum and minimum, and then we'll print out the values. So we need to add the code here to do that. When I call those functions maximum and minimum, I could have them return a max value and a min value. So I could use those 2 variables to capture the values that are returned and then print those out. But to illustrate that you can embed the calls to the functions in a cout statement, I'm going to show you how to do it that way. So I'm pasting in a cout statement. So I'm going to print out maximum value, then I'm going to call the function here. And of course that's perfectly legal. When I call the function, it will determine the maximum value, it will return it, and then it will be printed directly here. So I don't have to actually use that other variable in there. You know, alternately, I could have used the call up here, min is equal to maximum up there, you know, and then I could print out the value max. Okay, so either way you want to do it is fine, but just to illustrate you can embed calls to functions within a line of code, then I'm just showing you how to do it this way. All right, so this will call the 2 functions and it will print out the max and min, and then we are at the end of our program. So let's compile and run it. Now we have the results, so let's bring those over. So you see that the maximum value is 99, the minimum value is 0. So if we have sharp eyes, if we could look into it, there's a 0 there. So that certainly is a minimum value, and there's a 99. So we know that the numbers we're generating are between 0 and 99, so we would expect the max and min values to be what we see here. Now, in conclusion from this example, I have shown you the mechanics of how to write a function that will accept a 2-dimensional array. And again, the very, very important thing to remember is that you have to specify the number of columns in whatever function you're writing that includes a 2-dimensional array as a formal argument. Furthermore, once you decide on what that number is, the only array that you can pass in must correspond to that number of columns. Otherwise, you will get an error message. So when we did this up here, then we could call the functions with the array numbers because columns was 10. And that's what we set in all of our functions. We set it equal to 10. So I could not call the print array, the initialize array, or any of the other arrays. I could not call it with this 2-dimensional array the way it's currently defined. I would have to cheat and change the 4 to a 10 in order to use this array. So that's one of the things that you just have to be aware of when you're working with a two-dimensional array. And typically, if you don't know another way to do it, you just decide that I'm going to make this second dimension as big as I would anticipate any array being. And then you go from there. So you end up with a lot of extra wasted memory when you do that. In videos coming up later in the term, we will look at an alternate method to get around this restriction. All right, so this is a good example. This has a lot of detail in it. It has a lot of information about two-dimensional arrays. And I think you need to pay special attention to these details when you're working through the examples. All righty, as I like to say, all righty. I think we have reached the end of our time for this video, so I'll stop here.